Hello, everyone. It's me, Billy Younger, again with www.youtube.com/Billy Younger Physics Solutions. That's B, capital B on Billy, capital Y on Younger, capital P on Physics, and capital S for the first letter in Solutions. I have a lot of videos up there for mostly for physics, some math. Eventually, it'll have a lot of other things, but anyways, it's there. Check it out. Today, I'm going to solve a sort of real life type of problem, something that I actually do every time I go on vacation. Specifically, I keep track of my mileage, my gallons, my time, all that good stuff. And it gives us an opportunity to show you how to actually calculate, for instance, average speed. I know you've heard the word average a lot of times. You heard about averaging your tests, you heard about averaging your quizzes, but I need you to understand that there's a very specific definition of average speed. And later, of course, there's a very different definition of average velocity. And that's what this problem is about. However, in doing so, I also bring up things like miles per gallon, which might be called your fuel efficiency and stuff like that. So it's just a good all around physics problem for making you a human being that can compute things and make sense of things in the world. So let's give it a try. I'm going to start off by sharing a screen about the question I wrote. And here's the question. Says it takes me 11 hours and 23 minutes of driving time, i.e. I have cut out, i.e. by the way, I always read that as in other words, and e.g. I always read as for example, and that usually helps. So i.e. I have cut out the time spent stopping at restrooms, gas stations, restaurants, and scenic sites to reach a resort in Daytona, Florida. At the beginning of the trip, my car odometer reads 23,980.7 miles. And once I reach the resort, it reads 24,690.3 miles. However, I kept track of extraneous miles driven, looking for rest stops and so on and so forth. There were 3.3 extraneous miles. Finally, the total time spent leaving home was 13 hours and 52 minutes. In other words, that's the total amount of time I was actually away from home until I arrived at the resort. So that'll come in handy later. In part A, I want you to ignore the stops and extraneous driving and compute what my average driving speed getting to the resort was. Part B, I want you to take taking into account our various stops and extra miles, what was our average speed? So this might be a more realistic figure to use if you ever want to consider exactly how long it's going to take you to get from, say, in this case, it was from my house to Daytona Beach. And then finally, 3, if my Honda Accord used 18.479 gallons on the trip, what was my fuel efficiency, which I'm calling epsilon, in miles per gallon, aka MPG? That's another abbreviation we'll use, just like we'll use MPH for miles per hour. So the first thing you might notice is it takes me 11 hours and 23 minutes. And because I don't want to forget these valuable numbers while it's still up, I'm going to go ahead and write down the time. So road time is 11 hours and 23 minutes. And since I'm going to be using miles per hour, I really need to convert that to just plain hours. And what you do to do that is you say the whole number is 11, and then you say 23 sixtieths. So that's equal to 11 and 23 sixtieths hours. And you can actually compute that. 23 divided by 60 turns out to be 0.383. And I'm really only using 2 sig figs for the minute. So I'll carry 1 extra sig fig. And I'm going to call this equals 11.383 hours. So I've got the extra digit I'm using underlined so I can keep track of it. You'll see this in a second when I actually show it to you on my Google Docs, or actually on my GoodNotes or whatever app I'm using. That's one figure. I also have odometer readings. I'm writing them again now. You might want to do the same thing. Take time to write down these figures so you can work them out. Odometer readings. So the first one was 23 hours, or 23,907, 980.7 miles. And then the second was 24,000 690.3 miles. That'll come in handy. And I also said my extraneous miles were 3.3. And that would be like when I get off at an exit from my normal interstate driving to try to track down a Hardee's or something to go eat. So I'm going to call this extraneous miles 3.3 miles. Now, actual road time is the last thing I'm going to write down. Again, I'll show you all this that I'm writing right now. I just have to record it while it's in front of me. The actual road time was 13 hours and 52 minutes, which is 13 and 52 sixtieths. 52 divided by 60 turns out to be 0.86666. So I'm going to call this, and this is hours, by the way. I'm going to call this 13.867 hours, carrying again one extra sig fig. So that's the actual road time from the instant I left the house to the time I arrived at the resort. In part A, we're asking for the average driving time. And I'll say S average equals question mark only for trip. And in part B, I'm asking for S average. Counting everything. And in part C, I want to know, since I did use a certain number of gallons of gas, which I should also write down above, I want to know what my E in miles per gallon was. And gas used, I'll go ahead and record that. That was 18.479 gallons. Okay, so I now have sifted all the information out of that. I've tried to assign to it a symbol, say for each little quantity that's up here. That's one of the big things when you first start physics is being able to read through a problem, notice what they're telling you or what they're implying. Like for instance, if I say an object fell from a certain height, that implies that the initial speed was 0, and that's one of the things you want to write down is v sub 0 is, or s sub 0 is 0. But also the things they're telling you, and you want to identify them ideally with a symbol that you learned in your class. So now that I've gotten all that written down, let's stop sharing this and let's go to, again, in this case, I'm going to go to my document that I have in Good Notes, and I want you to see exactly what I wrote down. So you can see in this problem, I wrote down the road time, which is the road time that I spent cutting, and after I'd cut out the extraneous minutes, it turned out to be 11 hours 23 minutes, which is 11 hours and 23 sixtieths of an hour. 11 and 23 sixtieths of an hour, which is 11.383. Again, I carried one extra sig fig. The odometer readings, both the first one and the second one, to get the actual miles. Obviously, you would want to subtract the final reading minus, or you want to do the final reading minus the initial reading. And the extraneous miles, of course, you want to subtract those out, at least for part A. And then actual road time was the total time from when I left the house until I arrived at the resort, which was 13 hours and 52 minutes, which we'll call 13 and 52 sixtieths hours, which I rounded to one extra sig fig, 13.867 hours. And the total gas used was 18.479 gallons. And what I would like to do is find the average only for the trip. In other words, cutting out all the extraneous miles and minutes. Then I'd like to find the total average meaning not cutting out anything. And then finally, I want to find the fuel efficiency. So let's do that. So here's our solution. For part A, what I want to do is I want to say miles traveled. And miles traveled would, of course, equal 24,690.3 miles minus 23,980.7 miles. And that's going to give me, of course, I've already calculated this once, but it never hurts to do twice. So 24,690.3 minus 23,980.7, and that gives me 709. I shouldn't be using the word "and" in that, but 709.6 miles. And then let's say important miles. And for this one, we just subtract the 3.3 extraneous miles. So it goes 709.6 miles minus 3.3 extraneous miles. And that gives me, of course, 706.3 miles. So that's our total miles driven with the sole purpose of getting from my home to the resort. In other words, cutting out all the extraneous stuff. So the average speed is always, again, this is what I was talking about. Forget all the definitions you've heard of averaging. You're not going to sum up a bunch of speeds and divide it by the number of speeds or anything like that. That's what you do, for instance, when you're averaging test grades or quiz grades or bowling scores or something like that. This is not what you do in physics. In physics, there's a very specific definition for essentially everything, except once it's a new quantity, like something we just discovered. And the definition for average speed is the distance traveled divided by the time taken. And we even abbreviate that to just D over T. So the S average for this part, which I can also write as just S bar, is in fact going to be 706.3 miles divided by, now I've got to actually do the total time. And of course, the total time was, we've already calculated out the extraneous minutes. So it's actually 11.383 hours. So this is actually going to give it to us in miles per hour. So I'm going to do 706.3 divided by 11.383. Remember, that's one extra sig fig. So we should have exactly, there's 4 sig figs from the bottom number and 4 sig figs from the top number. So we should be able to round this to 4 sig figs. So the average speed is 62.04. Now, normally this is where we'd round it, but notice it's a 4. And there's a large number next to it. So if I round it to 5, you might think the next digit was something else. So what I'm going to do is I'm going to go ahead and write 4. That's my 4 sig fig, so everything's good there. And then I'm going to put 8, 6 right here. Actually, I can put 9 there. And that'll work because it's 86 is the next digit. And that's miles per hour, which we're going to abbreviate to 62.049 extra digit mph, just an easier way to write it. So that's our average speed over the trip. And again, that's just driving miles, not total time on the road, which is in some sense more precise, because really you have to know how long you're going to be on the road. All right, now for part B. for part B, we're wanting to know the average counting everything. So in this case, I'm not going to subtract out the 3.3 miles. I'm going to leave the total mileage to be 709.6. So S average again, which would be S bar. And I'll just put a full down here just to mean this is the full time we took. That again is going to be distance divided by time. In this case, the distance is 709.6 miles, again, 4 sig figs. And the total time is 13.867, because I already converted that, hours. So if I do 709.6 divided by 13.867, we get 51.17. That's the actual proper number of sig figs. I'll carry one extra digit. It's a 1 and an 8 after this, so I'm going to call this 2 and underline it and say that's MPH, which you all know is miles per hour. So it's quite a bit different when you take when you actually make use of the fact that, yeah, we actually had to stop. As you can tell, instead of it taking 11.383 hours, it took more like 13.867 because we stopped in 8 and all that good stuff. All right, finally, we want to know the fuel efficiency, which is measured in miles per gallon. And you'll notice such a formula doesn't exist in our book. A lot of formulas don't necessarily exist in your physics book. Miles per gallon is pretty self-explanatory, just like miles per hour is distance divided by time. You should think miles per gallon is just distance divided by gallons. So let's go ahead and do that. So part C, we have what we want to know, which is the total fuel efficiency. And I'm going to say only the driving time matters. So I'm going to definitely keep in effect the 3.3 miles. So I want to do that whole thing. And then I'm just going to divide that by the gallons. So keeping the 3.3 miles in, that's the 709.6. So E in MPG is going to be what we define to be miles driven divided by gallons used. Now, that's kind of tricky. So what I recommend when you're doing something like this is immediately before you leave, you want your gas tank to be topped off. And you ideally, go to a gas station, assuming you can put the pump in, the valve in, such that it only clicks once to say, hey, I'm full. If you've got one of those crappy ones where you've got some kind of bend or something in the tube feeding your gas tank, sometimes it'll click several times. You get 1 gallon in, your tank is completely empty. It's a 20-gallon tank. You're up to 3 gallons. It goes and stops off. That's not the kind you want. You might need to back the valve out a little bit, or back the pump in a little bit, something like that. But either way, you don't want it to stop but once, and you want it to stop basically near what you think is a full tank. So you get that right, get it at the right gas station, and you fill it to the brim before you leave on your trip. Okay. Now what you do is at the end of your trip, you basically would ideally, if it takes 1 tank, that'd be fine. You refill it. And when you refill it, you see how many gallons does it take to get exactly to that same spot again to the same spot where it clicked that first time. That's probably the most accurate you're going to get. It's not too far off, but if you take that many gallons, that's how many gallons it took. Now, in the case of this, 18.947 or 479 gallons, my Honda Civic had like a 12-gallon tank, and my Honda Accord's probably got like a 14-gallon tank. So that'd actually be 2 gas tanks. So what I would do is go ahead and fill it up a second time, record how much that first fill took, not the one before this trip, but the one on the trip. That'll be 1 number of gallons I use. And then when I finally get to the resort, as soon as possible, I'd fill it up again and write that down as how many gallons it used. And that, again, doing it the exact same way, wait until the first click, or, not the first click when you first put it in, but the first click when it's full. And you'd add those 2 figures together, and that would give you the total gallons that you've added in the tank for the entire trip. Once you have that, you can obviously calculate your fuel efficiency. So in our case, our miles that we travel were 709.6 miles. Again, I shouldn't be saying 709. That's not proper English. it's 709.6. And then the gallons used were 18.479 gallons. Okay. And I noticed my decimal on my gallons is not very dark, so I went ahead and fixed that. Now, if I divide 709, and I divide that by 18.479, it might help if my calculator's on, because evidently that's a lot better thing to do. 709.6 divided by 18.479. Looks like I got all the numbers written right. And that gives me 38.40. Now you'll notice there's 4 sig figs here for 709.6. There's 5 for the gallons, but the one with the smallest number of sig figs wins. So technically we're supposed to round it at that 0. Well, the next digit is also 0, but I'll keep an extra sig fig there. And that is miles per gallon, which we're just going to write as mpg. So that's another useful thing to keep track of. You'll find that usually if you have a fairly new car, it usually keeps a fairly good estimate of how many miles per gallon you're getting. And sometimes it'll be quite low, like when you're doing a lot of city driving as opposed to interstate driving. Whereas when you're doing a lot of interstate driving, it'll be quite high. My Honda Accord's actually a hybrid, so it actually gets quite a few more miles than that. We normally own the average of 40 to 43 miles per gallon. But anyways, that's some real good figures that I have here, and that's the typical way you can use physics day in and day out, as well as learning what the actual average speed is. So hopefully this will help you maybe in everyday life, maybe in losing friends that aren't cool like me and stuff like that. But anyways, that's it. Hope you all enjoyed it. Feel free, again, like always, in my comment section or the description section, you'll see a line that tells about how to contact me, and then you'll see a weird name that has, like, some spaces and stuff. That's generally the name of the file that I used to save that MPEG video. So if you ever need the actual documentation, whether you're my student or not, you can email me at that email address that's shown on the page, and I can get those documents to you. You just got to let me know what video it was. And it's usually that thing right under the very first line. Like sometimes it'll be PHY241 space 01222023. So if you let me know that, I'll know immediately. If you let me know the actual title, I'll probably know as well, but that other one's really what that's for. And that's also for people that I allow to subscribe to my Google Docs. They can just come in and do a search for that number. So I hope that helps. Have a good day.